Philea Rosetta. What is the purpose of Philea? Match the column type of a question, although they are not asking. Comet. Which comet? 67P. What's the other name? Churyumov-Gerasimenko. Got the name? Okay. Why it was in news? This project is over or started? Finished. It's finished. Of whom? NASA? European Space Agency. What is the difference between Philea and Rosetta? Rosetta, orbiter, and Philea, lander. Okay. But then it has been like, when it was launched? Come on. 2004 by European Space Agency to study the comet. Which comet? 67P or Churyumov-Gerasimenko. It reached there. Where? Comet. Which comet? I'm saying it for the next time. Okay. And again remember, comet. Osiris-Rex, asteroids. Okay. New Horizon, Pluto. Okay. This type of things you have to, I know it will get a bit confusing, but you have to do it. Okay, fine. What happened? Like, let me dramatize it a bit so that you can remember. Okay. See, Rosetta reached there in 2014. Where? That comet. It's not easy to pronounce it again and again. So, that comet. And when it was launched, 2004, it took 10 years. And just one point I will make. Like, India has specialized this technique we call as low energy transfer. Like we have discussed, like Mars orbiter mission. First it was placed in Earth-centric orbit, then we take it to Sun-centric orbit, then we take it to Martian orbit. Whereas US and European agency, they go for a straight path. Like Marvin, I'm just drawing analogy. Marvin was reached there 22nd September, we reached there on 24th September. How Marvin is different? I'm just giving you the analogy. Marvin was not going like this is Earth, then Sun, and then Mars this way. No, simple straight. This requires very higher quantities of energy. And here you are simply manipulating the momentum. So European Space Agency followed this approach. It was not low energy transfer. Marvin was also not low energy transfer. Just remind me, just 2 minutes I will be spending over there after this topic. What happened? Rosetta reached over there 2014. Philea separated from the orbiter. Okay. And it was having a tripod like this. Tripod you are having. It was supposed to land exactly this way. But somehow it got tilted. And when it tilted, it landed this way. And its solar panels got in a direction opposite to that of Sun. And obviously, as a result, when solar energy was not there, and means solar panels were not getting the required quantity, there was no electricity. So obviously, Philea decided to go into hibernation, which some people do in the class as well. Hibernation, because lack of solar energy. That is the case. But obviously from there itself, obituary was written about it. There is no viability. But later on, somehow, some bit of this thing, solar energy was received, and because of that, the batteries got charged for some time, but again got discharged. The problem is now this comet was moving away from the Sun, and now as it was moving away from the Sun, you have to be practical. That is science. There is no possibility of increased solar insolation. Rather, the insolation will keep on decreasing. So they thought there is no viability. So later on, what they did, they have crashed Rosetta onto the surface of that comet, because Philea was already there. Rosetta has been crashed, not Philea. And with this mission has been closed. They were looking to study that comet. That is what we call a 67P. Or you say that at least by looking at it, you will be able to identify Churyumov-Gerasimenko. Oh, this was the name we were hearing in the class, and take it and move on. Now, just one point just listen to me. If, say, for example, you get this question, because ExoMars mission is in news. ExoMars we have discussed. Like, say, for example, they will give you 3 missions. One is MOM, second is Marvin. Marvin is of NASA. And third one is ExoMars mission. Okay, here one possibility of a question is, of the three, the human transfer or low energy transfer was used by MOM and ExoMars. ExoMars is the first because it has been there in January 2016. This one reached. ExoMars is the first after Mars orbiter mission to follow the same principle of transportation as done by Mars orbiter mission. And that is what we call as low energy transfer. Low energy transfer means first it was placed in Earth-centric orbit, then it was transferred in a Sun-centric orbit, then from there it is taken to the Martian orbit. Whereas in case of MAVAN, they have gone for this straight approach. Is this clear? Okay.